Let us now look at implementation of a logical function using a multiplexer. So here is a 16:1 multiplexer. It has input lines from I0 to I15, that is 16 input lines, and 4 select lines, S3, S2, S1, S0, and of course one output. Now using this multiplexer, we want to implement this function x equal to a b bar c bar d plus a bar b c bar d bar. Let us see how to do that. Let us first prepare the truth table for x, and step number 1 would be to enumerate all the input combinations, and that is what we have done here. And a systematic way of doing that once again is to allow d to change every single entry, c to change every 2 entries, 0 0 1 1 0 0 etc., b to change every 4 entries, 0 0 0 0 1 1 1 1 0 0 0 etc., and a to change every 8 entries. So we have 8 zeros followed by 8 ones. Alright, now this x has got 2 minterms, and therefore we will have 2 ones in this truth table. Where is this one located? It corresponds to a equal to 1, b equal to 0, c equal to 0, and d equal to 1. So it is 1 0 0 1. So that is right here. So that is the first minterm. This second minterm corresponds to 0 1 0 0. So that is right here, and of course all other entries are 0. Okay, so let us now talk about our implementation. The mux output is the same as our logical function x, and these select lines are connected like that. S3 is A, S2 is B, S1 is C, and S0 is D. And notice that this order is the same as this order here, and that makes it very convenient to make connections to these input pins, as we will see. So what is left now is to make connections to these input pins such that we get this function at the output. Okay, let us look at the minterms in our function. The first minterm is a b bar c bar d, and when that is equal to 1, we want x to be equal to 1. That means when a is 1, b is 0, c is 0, and d is 1, we want the output to be equal to 1. That entry is right here. So when that happens, when we have 1 0 0 1 here, what happens in this multiplexer? 1 0 0 1 is decimal 9, so therefore this I9 gets connected to the output, and we want that to be equal to 1. So therefore what we can do is to connect 1 over here to this I9 pin. Similarly, we can treat the second minterm, and that minterm is here. So ABCD is 0 1 0 0 in that case. Now 0 1 0 0 is decimal 4, so pin I4 gets connected to the output, and therefore we should make I4 also equal to 1, like that. And these are the only 2 minterms, so therefore in all other cases, that is for all other combinations of A, B, C, D, the output must be 0, and therefore we can connect all other pins, all other input pins to 0, like that. So that is our implementation of this function. Now in this example, since the truth table is organized in terms of A, B, C, D, with A as MSB and D as LSB, and that is the same order in which A, B, C, D are connected to the select pins, the design is particularly simple. This order and this order is the same, and therefore what we could do is simply reproduce this column over here. and that would work. Let us now implement x equal to a b bar c bar d plus a bar b c bar d bar, which is the same as the function that we saw in the last slide, using an 8-to-1 multiplexer now. And here is one possible design. The output of the mux is the same as the logical function that we want, and the select lines are connected to A, B and C. Now this choice is not unique, we can have some other choice, but suppose we go ahead with this one. Let us now figure out what we should connect at these input lines so as to get the desired function at the output. To begin with, let us prepare a truth table in terms of A, B, C, since those are the variables which appear over here, and we will treat A as the MSB since that is connected to S2, and C as the LSB since that is connected to S0. And we write these input combinations in the same manner that we described earlier, and with A as MSB and C as the LSB, this number corresponds to decimal 0, this one to decimal 1, decimal 2, 3, 4, 5, 6 and 7. Now to complete this column, let us look at our minterms. This first minterm has A, B bar, C bar, and this part is 1 when A is 1, B is 0 and C is 0. That is 1, 0, 0 here. And when that happens, our x becomes equal to D, and this part of course is then 0. So that is why we have x equal to D over here. Similarly, consider this minterm. This A bar, B, C bar is 1 when A is 0, B is 1, C is 0. So 0, 1, 0, that is right here. And when that happens, x becomes equal to D bar, 1 ANDed with D bar, that is D bar. So that is why we have D bar here. And in all other cases, x is equal to 0 since we have only 2 minterms. So that is how we have prepared this truth table. The rest is straightforward. We can now consider these minterms one by one and figure out what we should connect over here. Let's take this minterm, that is right here. So we have A, B, C equal to 1, 0, 0. 1, 0, 0 is decimal 4. So this line I4 should then be connected to D, like that. The second minterm is here, and in that case our ABC is 0, 1, 0, that is decimal 2. So line I2 should then be connected to D bar, like that. And in all other cases, x should be 0, and therefore we connect all other input pins to 0, like that. So that is our design. And once again, since this order is the same as this order, we could have actually just reproduced this column over here rather than looking at each of these minterms once again. Alright. Now there is some homework for you. Implement the same function x with s2 equal to b, s1 equal to c and s0 equal to d.